Okay, hello, my name is jmerelo. Can you hear me over there? Yeah, okay. So I'm going to talk about this, how to teaching and learning programming. Let's try to do it right. I'm jmerelo at Cepan and jmerelo at Twitter. So please, if you do some picture or whatever, just tag me. You know, it's a mystery. It's a real mystery. You know, right today, it's been 90 years since Agatha Christie disappeared. Then she showed up 11 days later in a spa. But anyway, it was a real mystery at that time. One of the persons that was researching that mystery was Sir Arthur Conan Doyle. You know, we are right by the side of Baker Street. So I think it's a great place to talk about mysteries. And the mystery I'm talking about is why we keep using Hello World as the first thing that anyone learns about a language. I mean, it's a real mystery. Just think about it. It's something that was written like 30 years ago, when the only thing you had were one-line terminal, and everything was I/O driven, and it was driven by the console. But we got like fancy things now, and still, if you open randomly any book that teaches any language in the world, you will see Hello World. So I will try to say goodbye to Hello World once and for all, and also for several reasons. Think about the last time you tried to learn a language. Probably you didn't do it. I mean, I'm still faking with Perl 6. I have absolutely no idea. I mean, this afternoon I'm a little bit better since I went to Jeff talk, but still, I mean, I try to write things in Scala. I have no idea about Scala. But kind of, you know, I put things there and they do things. And so, but the reason is that, I mean, I didn't have a formal education in computer science. Is that the case for you? I mean, raise your hand if you don't have like a computer science degree. Yeah. No, I'm a theoretical physicist. So the first thing I learned was BASIC. I had a Spectrum, and I kind of browsed through the thick manual that came with the Spectrum, and I learned a little bit of BASIC. Then I learned a little bit of Pascal. Pascal, if you think about it, it's a very nice language. It wasn't intended as a language for doing real things. It was intended as a language for learning computer science. I was very good at that. I mean, now there is even some people that use free Pascal, or even some people that wrote something in Borland Pascal like 20 years ago, and it's still running. But then I had to learn something serious, you know, for my PhD and all that. And I got an excellent book that was called C for Native Pascal Speakers. I mean, there was such a thing. So most people were learning from Pascal, because that's what they, I mean, when they learn a little bit, either by themselves or some kind of formal training. So most people had learned Pascal, but then you had to like learn completely different things you went to see. And this is still what we do. We learn a new language, and we have to learn a new language almost every single day. Think about it. You have been running Perl for maybe a long time. You have been in Perl for maybe 20 years. I had to make a big change when I went from Perl 4 to Perl 6. I mean, from Perl 4 to Perl 5, and then I still have to learn a new language. Languages are living things. They change almost every day, and you have to learn new things every day. So I think it's very important that okay. So I think that changes now. So that kind of things, that kind of experience you have when you learn a new language, that kind of progress you have, I think that it could be fixed if we just learn programming languages in a completely different and new way. I think the change is now. I think that it's about time we change the way we teach and learn new languages. I mean, maybe for us it's a little bit too late to, you know, learn from scratch, but I keep seeing people, I mean, my computer science students, I teach in computer science in Granada, and I see people when they are to the fourth year, they are really, they have like, you know, kind of the worst practices in the world. You know, my two daughters are starting now computer science. Different issues. First thing is that they are learning C++, so their first language is C++. Just imagine. C++ as your first language. Second thing is that they are not taught to love what they are doing. So they say, okay, I'm doing this because I got to learn this, but it's not like this big enthusiasm about, and it's not a problem. I keep saying them, this is bad, this is bad, this is bad. I say, okay, but I have to do it because that's a way to pass. You know, just imagine, in one occasion I told them that you should declare variables when you use them. And they actually used that in an assignment. They got -1 because of that. Because they are taught to declare every variable at the beginning of the program. Why? Because that was the way it was on when they were learning COBOL. And that was the language they learned when they did it. And my point is, we must kind of, maybe at a university level, maybe at a structural level, maybe at a company level, teach programming for newcomers in a completely new way. Yeah, and it shouldn't be too difficult because most languages look pretty much the same. You just look at this. Okay, look at this. This is if I, do you know this? No, it's a Scala. Do you know what it does? You can pretty much make out what it does, right?
What's the method to class?
Yeah, it's a method. It's counting the number of ones. It's a recursive method for counting the number of ones. I mean, if you look at it a little bit closely, you know, it's got some you know, the syntax and things. But at the end of the day, you say, okay, if I look for, say, 10 minutes with my experience, I know what it does. And then if I want to do something else, like, you know, printing the result or some kind of debugging, I can pretty much make out my way. So most languages look pretty much the same. Even this language, which is Haskell, it's kind of hard. But still say, okay, it's folding. I don't know what fold does, but then you are doing this X, and then return E plus 1 else Y, 0 B. I really can't figure that out. But anyway, so it kind of does something that I can make out, which is counting the number of ones recursively. And this is the most extreme case. You can maybe, you know, look at it, run it. So my point is that many languages look pretty much the same. They have the same kind of, you know, syntax. They have the same, maybe texture is the right way of putting it. Okay. Problem with languages is also that they have a finite lifespan. So it means that if you learn one particular language, like C++ or Python or Perl or whatever, it's going to end someday. It's going to end because it's going to evolve into a different thing, like Python 2 and Python 3. Maybe it's going to change like Perl 5 to Perl 6. I mean, Perl is still Perl, but it's completely different. And there's going to be a lot of resistance to change. People will not want to change. They say, I learned this, and I can pretty much make my way in this way, so why should I change? Not to mention that nowadays you have to learn many different languages, because wait. Okay. You have to keep learning all the way. So I have been programming for maybe since 83, something like that. So it's been 33 years already. And I keep learning languages. So now I'm trying to learn Go. I'm trying to, because it's useful. I mean, I can do some things easily in Go that in any other language. And I also wanted to test some things. So you never stop learning. You have to learn all the time. So I think it's good to have a base that, or a foundation that allows you to learn more efficiently. So you have this. So I'm not sure about this. Let me check. Okay. Yeah. So I think instead of being resistant to change, we should surrender to change. We should say, okay, it's going to change all the time. I'm going to learn a new language or a new language feature every 2 weeks. So we should try and do that. And we should do that from the very beginning. So since the first time we do our first lines of code, we should kind of do this. So how can we do this? The first thing is that we should focus on real tasks. So just think about what I just said. Print F or cout, hello world. Nobody has ever done that. Never, ever. Just think about real tasks. Think about creating a website. Think about checking something out from a database. Because one of the problems when you teach something is that you assume that the whoever is learning knows nothing. Also that he or she can't understand what's going on. So if you look at some code from Scala, for instance, maybe you don't understand everything that's there, but you kind of find out your way there. So if you show real tasks, you show real things that are being done, even if people can grasp completely what it's doing, it's going to learn something, right? And then show real code. Nobody has ever done printf hello world. Nobody has ever done, a paycheck application in the console asking, please press 1 if you want this, please press 2 if you have that. I mean, people are still teaching things that way. Not to mention that you can use ANSI terminals. Terminals are now like full screen. You can do that on the web. You can do that everywhere else. So show real code, even if some part of the code is not completely understood. I think that's very important. And the most important thing, you have to teach programming in any language. Because anyway, you're going to have to use many languages at the same time. So how many of you work routinely, like every month or let's say every year in, let's say, 5 languages? Come on, raise your hand. I mean, you have Perl, you have JavaScript, you probably are using something like R, you probably are using something like TypeScript, which is maybe a different language, Perl 6, maybe some other things like probably Python, or probably something for provisioning, and you're using Ruby. So you're using some language like SQL. HTML is not a Turing complete language, but still it's a language. You may have testing out some R, maybe some Scala. I mean, even if you don't do anything, you will be using like 3 languages. So you might as well have people learn every language at the same time. And then you have to embrace the internet. So it's absolutely stupid to have a table this big with every single command that you can do in some particular environment. It's stupid. That's on the internet. People are not going to remember that. It's impossible to remember that. Nobody remembers that. I mean, think about the Scala. Scala has got like 10 million keywords, give or take. It's impossible to remember. When you do something, I mean, I can pretty much make my way in Perl, but every time I need to know the length of an array in JavaScript, I have to look it up. I don't remember if it's size or length, if it's a method or if it's a variable. I really can't remember. So I have to look it up every single time. If I have to do some regex on JavaScript, I have to look it up because I don't remember if it's match, if it's check or whatever. So I mean, just don't try. Don't try to do it. The internet is there. Stack Overflow is there. So you really have to check out the Stack Overflow, and people are going to do it. So you could just as well. And also, you have to take into account that almost everything you are going to run, you're going to run it on the internet. You have to do web first, because web applications are what you do nowadays. You don't do command line applications. You don't do desktop applications. I mean, people do that all the time. But web goes first. And then, and this is the suggestion of Neil, you have to stand on the shoulder of giants. Why create some little nifty snippets of code with every single concept that the students should know in that particular moment, and not use like real code that has those concepts there? You look it up in GitHub, you look it up in some module repository like NPM or like CPAN. It's right there. It's excellent code. It's code that has been running for 20 years. Just show that code. Don't show your little stupid snippets of code, because, I mean, it's going to be absolutely useless. People are not going to learn. And then this is a very important thing. So nowadays, everybody's programming. Journalists are programming. Biologists are programming. Computer scientists are programming. Everyone is programming. So you have to give power to the user. You have to give power in the way that you have to really show what they can do and what they can learn. Remember, I was giving a talk on regular expressions, to journalists. It was a 2-hour talk. They were happy, absolutely happy. And I was using some very simple thing. I was just telling them to use some code, some things like, you know, look up regular expressions on the web and check them out. They were happy that they could do things. They were receiving power. Just imagine that programming is not only to create application, it's also to create macros for your word processor. Do you know that you can program PowerPoint? You can actually program it, PowerPoint or Impress or whatever. Actually, I think you can do it in Python and in JavaScript. So you can have the slides just like this. This is reveal.js, and you can use JavaScript here, and I have used it from time to time. But you can, I mean, if you tell people that they can program things, they can kind of, you know, create some jiggle the slide or do some actual programming in the thing. They will be quite happy because they will be empowered. If you show them how to do stuff in a spreadsheet, even in a game, even in a camera. I had a Canon camera, and there's something called Canon Hackers Development Kit. Have you used that? Yeah, it's absolutely amazing. And you can program it in Lua. And you can make a program run when you click, so that you can insert all kind of things there. So if you tell people that, you will have photographers programming, you will have all kinds of people programming, and not saying, no, this is not for me. You know, it's, you know, programming is that's for geeks. No. I mean, you tell them you can do that, and you can empower people doing that. And it's also true that there is no true paradigm. So there are some languages that are paradigm free, like Perl, for instance. If you want to learn every single paradigm, you go to Perl. You go to Perl 6 if you also want to learn concurrent programming. But you have functional, you have object-oriented, you have concurrent, you have everything. So maybe it's the single language or that kind of language that you should use. But there is no true paradigm. The world is not object-oriented. The world is not procedural. The world is not type-safe. It's not duck typing. You usually have all kind of things. Anyway, functional is probably the way to go. If there is one single paradigm that's true, I would say it's functional. I don't know if you agree with me. Raise of hands if you agree. Okay, so the true paradigm is object-oriented? No, it's not. Come on.
There is no true paradigm.
There is no true paradigm. But some of them are truer than others. Anyway, and this is also the most important thing. You should teach ecosystems, not a language. A language by itself is nothing. It's just a bunch of syntax. So you can have the most awesome language in the world, like, I don't know, Haskell or whatever. But if you don't have a thriving community, you don't have an inclusive community, you don't have places where you can look up, language is going to be nothing. You know, I mean, all these things I learned from Perl, because this is one of the things that having in Perl from the very beginning. You have the onion. The onion has got those many layers, so you have to really teach the onion, not only the language, but the onion. That's also very important. So, this is kind of a manifesto. Do you think that you really want to follow that manifesto? I don't know about that, but I think that it's very important that people nowadays have to go full stack. So you no longer see things like front-end developer, back-end developer, you still see that. Most people have to do some kind of full stack, but not only full stack. They have to do full queue, full data store, full any kind of thing. So they have to program at any end of the spectrum, from creating, you know, using DevOps to define some software-defined infrastructure, to, you know, program JavaScript or program a data store using some language like JavaScript or SQL or whatever. So you really have to go full stack. So it's something that's really needed, and you know, that means that you will have to learn many languages, and you will have to use many languages. And then polyglot is the norm. If you think about the software architectures like microservices are polyglot. They are polyglot by design. So you are going to, one service is going to be written in Go, another one is going to be written in Python, another one is going to be written in Perl. And maybe you got something running, some API running that's maybe written in whatever, Scala or anything else, or R, or you name it. It's probably going to be there. So it's always been that way. So if you work in the web, you will always need to use JavaScript, or maybe you need to use something that compiles to JavaScript. But then you still have to know many languages. You have to know some data storage language. You have to know query languages. You have to know, like, say, data structure querying languages, like CSS, like XPath, like things like that. You always have to know many different languages. And you could as well start to do that from the beginning, as I say. And it's also, that means that when you go into a project, you have to hit the ground running. So you can't limit yourself to projects that are using the languages you already know. You have to be ready to use any kind of language. If you got experience like 20 years or 50 years, even 10 years experience, it's not going to be difficult. You get into some place that's using C Lisp or OCaml or even Kotlin. You know Kotlin? I don't know Kotlin either. It's a complicated language. But anyway, or Swift, Objective-C. I once had to do something in Objective-C. It's probably one of the worst languages I've ever used. Before TCL. Because TCL was terrible. Anyways, you are into there. You're not going to have time, like 1 month time, to learn a new language. You have to hit the ground running, like see the code, see what's going on. Maybe look it up a little bit on the internet, say, okay, a couple of days, you're up and running. And then finally, you got to get the job done. A short time ago, I was looking for some code for writing a Telegram bot. And I look it up. I had to have it running like in 2 hours. And I look it up in Perl. I say, no, not exactly what I'm looking for. I look it up in Python. I say, no, not really. And then I found something in Go. And I got it running in 2 hours. So I wanted to get the job done, which was having a Telegram bot running. And Go was very easy to understand, very easy to set up, very easy to put it there. And I just did it. I just got the job done. Maybe I could have done it in Perl maybe in 2 days, or maybe 1.5. But the way to have that job done in time was to use Go. Go is an awesome language, by the way. I think Go is the next C. And C is the next Scala. And Scala is the next Java. And Perl 6 is the next everything. Anyway, so if I write the book, that's the index of the book, by the way. I wrote it. I wrote the index of the book, not the book. So if I want to do the book, I don't try to do it this way. I'm really open to any kind of suggestion. So you still have to teach the things, and you still have to teach some languages, and you have to really do the working if you want people to embrace this kind of this way of learning. So this is what I have written. So you have an Aleph, which are the principles. You got it? Aleph. And then you got the alpha and beta, which are the motivation and why. And then you got the actual syllabus of the book. First one is that I will start with expressions. Not print, hello world, not anything, just simple expressions. Because think about it. Many languages have a rep, and in that rep you can type expressions and it will think. And in some cases people don't really know how to create a complex expression. And in this thing you also have to put in Unicode so that people know how to use Unicode strings, how to work with Unicode strings. Maybe even talk a little bit about regular expressions, because any language you're going to use, you're going to work with regular expressions. And just work with that. Also work with spreadsheets. Also work with the command line, because you can evaluate expressions from the command line. You can do many things. You can get a lot of things done using just expressions. And I think that's very important. You should really devote a lot of time to it without getting into any other thing. without getting in how to print that expression. No, you really don't need that. You go to this browser, you open the developer console, you start to type things, and you get the result. And you really have to get a grasp of how to combine strings. What happens if you try to add a string to a number? That kind of thing. So I mean, I think if I do it eventually, I'm going to start with that. So you see, it's right there, doing stuff to that. Another thing I'm going to use is not use any complicated language. So I'm not going to talk about algorithms. I'm not going to talk about loops. I'm not going to talk about any kind of thing. I'm not going to use any kind of jargon, but call things in just the way you would do it if you were teaching to anyone that has no idea, not even doesn't have any idea, but also doesn't want to have any idea. She just wants to have the job done. Another thing is, I will try to work with functions. So not saying, okay, you can do subroutines or whatever. No, talk about functions. Functions are a thing. I have said before that probably functional is one of the most important paradigms. I would say that you really have to devote a whole chapter to just talk about functions, talk about the state, talk about recursion, talk about that kind of things. Maybe use examples that are from functional languages, but maybe also anonymous functions, closures, that kind of thing. I think it's very important, and people don't pay enough attention to that. If you know the concepts, you can pretty much seek you into learning functional languages very, very easily, and you can also use function in any other kind of language. So I think that's a thing. And this is also something that I have noticed in my students. When they have an error, when they get an error, they usually start all over again. So they are quite afraid of errors. They get the heebie-jeebies if they see one error. Why? Because they are not taught to deal with errors. They say you should do this and you should do that and you should do that, and then you are going to obtain that, and that's it. And what if I don't? Okay, you look it up in the Stack Overflow, but still, you have to know what to look it up, because you will usually get like 2 or 3 screenfuls of errors. You have to know where the origin of the error is. In some cases, you got like very nice error reports, like in Perl 6, but still, you have to really read it and understand it, and know what to do about errors. You know, I learned quite a lot from errors. When I get into a new language, I do something, I get an error, and I say, okay, what's the deal here? I look it up, I fix it, and I learn more from errors than from any kind of book. But you have to get that built into the way people learn. So like devote a whole chapter to errors and how to deal with them. Compile errors, runtime. People don't even know if it's a compiler error or runtime error. They say it's an error, so it doesn't work. But what happens? Okay, it doesn't work. So I will start all over again, and I will reinstall Linux, and then I will kind of do this again to see what happens. No, you can usually fix it. I mean, errors nowadays are usually quite helpful. So you kind of have to teach people how to deal with errors and how to learn from them and how to fix things from the interpretation of the errors. And then finally, you have to do stuff in the cloud. The cloud is some other guy computer, but it's also the place where you run applications nowadays. Everything you are going to run it on the cloud. So it's not like you finish this, you create an icon, you click here, and then you run it. Or you finish this, you compile, then you go to the command line, you write the name of the program, and that's it. No, it's not going to be that way. You have to define the infrastructure where it's going to run. You may have to put it into a Docker container, or maybe you have something else on the cloud, and you have to define the infrastructure via Ansible or Rex or whatever. Then you have to deploy using some other tool like Capistrano or Fabric or some other thing. Then you have to monitor what's going on, because as long as you're running something over the net, you will also want to stop it. So you have to use some running thing like I don't know, there is something called PM2, for instance, in the Node world. Then that cloud has to be taught from the beginning, because it's where programs are going to be run eventually. And then you also have things that are not like really programs. You heard about Amazon Lambda, for instance. Lambda is like teeny functions that are running on the cloud. It's functions that are connected to an enterprise bus, and then they get activated when something happens, and then they run for a few seconds. I think that the maximum is 2 seconds, and then they disappear. It's like very incredible, lightweight virtualization. So people are going to do that. Also, when you work, for instance, with Google Drive, you can like write small snippets of JavaScript, and you can have things done when something happens. For instance, someone fills a form, and then you want something to be done about that. So those are the places that are going to run things. Or even you're going to run something into an ESP8266. You know about that? It's like this little teeny Wi-Fi chip where you can run things. It's like an Arduino, but even smaller than Arduino. So you will have to upload things there. So running is not writing something on the command line. It's not clicking something. It's usually running things on the cloud or some other system or whatever. And you really have to pay some attention to that. So Perl. Perl is kind of the thing that started it all. So for me, it was like a the language to finish every other language. Since I started to learn Perl in '93, I think. I have been using it ever since. I have abandoned many other languages. I was using Pascal, I was using C, I was using C++. I have no idea about C++ now. But if you look at Perl, Perl is a little bit like this. It's built of many different parts. So if you have to learn a single language, Perl is probably a very good choice, except for sigils and things like that are kind of weird. But it's a very good test bed for teaching every other language, along with things like teaching CPAN files, teaching recs for deployment, teaching the community, teaching CPAN, which is also part of the language, teaching many other things. But you need kind of expand what's happening to Perl, or the concept, the high concept of Perl to many other languages, and you kind of have to teach them along, or have them along in a book if you want to teach them. And that's basically it. So this is the GitHub for the book. Right now it's a .org file. So I really need you. So I don't know if it's like, it's something crazy that I just thought about. It makes some sense. Maybe it doesn't. For me it makes, but maybe I'm the only one. So I really need you. I need you to some feedback on it. That's a repo, so just do some pull requests. We are in Advent, so you have this 24 pull requests. So I don't need you personally to do the 24 pull requests, but if anyone does anything, so it's right there. So I'm probably wrong in many things. I kind of, it's something I have been thinking about, but as I say, I don't know if I'm right or not. So I would really want some feedback from you. I would eventually like to write some book on this. So the draft is there. I think it's really worth a while to have a book that shows the way programming should be taught in the 21st century. But that's enough for the time being. Thank you very much. I think we have time for questions maybe, or we're done?
You mentioned that Stack Overflow is a place to go and look for ways to learn a language.
Yeah.
I hope you're not serious, because if you look at Stack Overflow contributions to questions about, for example, C++, there's a different answer to every person who answers. Source of misinformation quite often. It's not best practice. That probably applies to other
Stack
languages.
Overflow. The problem with Stack Overflow is that some questions and answers are there since 5 or 6 or 7 years ago. But it's still the only place where you can ask some questions and some difficult things. But I also said that it's very important to know the community. So maybe some particular languages have some particular IRC channel, or maybe some of them even have Slack channels. So you should know about that. You should know, and it's also very important to really become a part of the community. So if you have some popular language, you probably have some local user group, like Perlmongers or whatever, where you can go to. So Stack Overflow is nice. You should acknowledge it. You should also know that it's dangerous. So sometimes if you do a question that looks lame, you're going to be insulted, you're going to be trolled, and all that. But it's part of the community. It's a resource you can go.
I think
So-
you could very happily have a full chapter on just how to find things out and actually say things like, you know, you will get, it'll be easy to find things out if you are part of a community, and
Yeah.
talk about what that means and how you become part of the community. And there's a whole, I mean, there's pretty much a book in that as well.
Yeah.
But
I mean, there's a book in every single thing. You think about expressions, there's a book there. You think about, like errors, how to interpret errors. And when I'm saying errors, I'm saying error in every possible language, present or future. And it's going to be hard, but I think it's worthwhile. So it's first JJ, the other JJ, and then you. Yeah.
So when I've had to teach programming to people who normally come from places where they don't do it, what I try to focus on is to teach them how to think like a programmer. So how to break down a problem into smaller problems. And that is also, that sort of matches with a lot of the things that you were saying, being sort of language agnostic and empowering the user and those things. But I find that oftentimes the people that I'm teaching come with that mentality of like, let's get the job done and move on. And that what that creates is a long trail of really awful code that is unmaintainable, it's just a pain, and that they themselves don't understand, that they cannot use in the end. So that's why I've always sort of tried to focus on not get the job done, but like understand sort of how to approach the problem. And I just wanted to know what you thought about that, because it doesn't seem to completely align with what you were saying.
But I have mixed feelings about that. So on one hand, I really hate cargo code programming, because it has kind of puts a lot of craft into some code. But on the other hand, I think that cargo code programming empowers people, because it allows people to get the job done. So just think about regular expressions. If you think, okay, I'm going to teach regular expressions, then I have to, people have to know what's a grammar, then people have to know what's a regular kind of grammar, then you have to know all kind of characters. No. You have to do it in 2 hours, and to journalists. What do? You put a lot of cargo there, and then people gets the job done. They are not going to program like an enterprise ready back office, but they are going to do something that needs. So as I say, I'm kind of mixed. Sometimes in Spanish we say lo mejor es enemigo de lo bueno, which means the best thing is an enemy of what's good enough. So sometimes we have to settle for good enough. We don't want people to be good programmers. We want people to program. And I think that also relates also to the diversity of the community, because most people, I mean, just look around you. How many women are here? It's 2, 3, 4. I mean, it's absolutely appalling there. So I have been in several talks before, and there were no single women there. So, but on the other hand, I go to game things, and they are there, and they have been learning programming just to program games. So, and that's another thing. You should think about putting examples in games, but not show the whole thing. No, I have to teach them how to work with OpenGL and then this kind of Blender thing. No. Just change this and change that, get the job done, and that's it. And you are a programmer. I mean, I don't have like a very clear cut, but I don't know if you get a little bit my idea. So I want the community to be diverse, the community of programmers in general to be diverse. I want to attract people to the community, and I want also the community itself to be able to change. So that's not an answer to your question, but anyway. So
You've answered my question.
okay, thank you.
But if you look at the total cost of ownership of software, the initial cost, the cost of the initial development is often minute. The real cost comes from maintenance, the years of other developers struggling with the crap that somebody's started with in the first place because they just closed their eyes, they didn't think of generic code, maintainability, this kind of thing. You can't just hack something and move on.
Yeah, but
You're putting a barrier, you're putting a huge cost.
But I don't want you to see my point that way. I really want to teach people that at the same time. For instance, I want to teach them testing from the get-go. documentation from the get-go. That kind of best practice. Best practices should be built in, and best practices are usually transversal. So if you teach them to do best practice in any single language, they are going to use it if they go to a. But relating to that, Dave, for instance, he was telling us about some old Perl system that are still using 5.8. Why? Because they don't embrace change. They don't surrender to change. They are very resistant to change. So if they just go with the flow and start to change and learn, 5.12 or 5.16 and do it from time to time, it's going to be much more difficult. And also the problem is that Perl doesn't have so many programmers around, which is good because you get good wages and all that. But on the other hand, it might be bad because you have some legacy code to maintain and might be a pain. So I don't think that in the long, I don't know how it will result. I mean, it's just something that I'm like releasing to the air to see what happens, or throwing it to the wall to see if it sticks. But I think that in the long run, you will have many more programmers, the community will be more diverse, and the total cost of ownership will decrease.
Could I just make a separate point as well?
Sure.
I think you're very lucky. I think you're obviously working in an academic environment where you can cherry pick the best tool for your job straight off the internet. A lot of developers working for commercial organizations, they may be air-gapped from the internet. They have to be very careful about only using accredited software. So it's very difficult to switch and decide, well, I'm going to use Go instead of Perl or whatever, cherry pick the language.
Yeah, but
They don't all have freedom to do that.
still, those organizations have to hire new people, and they probably don't have exactly the person for the job. It's very difficult nowadays to have exactly the person for the job. So I know that in Spain, for instance, some guy was complaining the other day on the internet that he couldn't find a senior PHP programmer. Just imagine, senior PHP programmer. But a senior Perl programmer can do PHP in no time, if he just wants to embrace change. So I don't know if that answers you. So of course I'm lucky that I'm not only in academia, I'm a full professor, so I mean I don't have to worry about anything. But but still, people are very resistant to change even in academia. So what I'm seeing now is a lot of resistance to change in academia. So they are not. I was talking the other day to some student. He was studying in some university, not top tier university in Spain, let's say second tier, computer science. He hadn't seen a single scripting language. Not a single one. Not even PHP. I mean, if you consider PHP a language, which it's on the side. But
The point that I'd like to make is that we're perhaps of a certain age and we've become quite elitist in our views on programming. That protects our particular world. Trying to get anybody interested that's younger than us into programming is very difficult. They're not interested. There's no traction there. There's very little. And I've always won with the idea of disposable code. I'll do hacks and I'll delete them. How many people delete code after they've used it? I mean, sometimes you've got to do some data processing, so you write some scripts and stuff just to get the job done.
yeah,
And then you keep them, then you wonder what the hell they were and how they worked. It's much easier just to delete them, and next time you do them better. And that's also a discipline that we've learned, sort of as we get older. And the point that I'm trying to make is that a seasoned programmer could easily learn another language, but somebody who's got a language, and we've all seen it. Someone's got some obscure language, which is what the customer wants. But that's the only language they've got. They can't program. Meanwhile, we could pick the language up, pick the syntax up, probably in a couple of days, and have overtaken them, within the first week. And that's got to be something the marketplace has got to understand as well. That there's value in that rather than just learning syntax.
yes. But what I want to have with this kind of book or whatever it becomes eventually is to have that kind of experience distilled into a single book. So that just imagine you have like 3 chapters, and then the 4th chapter is, okay, now we are going to see all this in this particular language which I choose. Okay, then you have couple of chapters more, and then another chapter that say, okay, we are going to see this in this other language, whatever. So that kind of experience could be had by someone, not the experience, but maybe the skills, kind of the skills. It's like, I mean, doesn't it happen to you that you look at a program and say, this is wrong? I don't know what happens, but this is wrong. This is just plain wrong. Doesn't it happen to you? Just you kind of see the texture of the thing and say, this is wrong. And that's something that, I mean, it's a skill. It's not a miracle. It's not magic. Something that, if it's a skill, can be taught. But if it's got to be taught, you have to kind of distill that experience into something. And that's something I would say is be language agnostic, teach something that goes across every language, and so on and so forth. So I think we don't have more time, right? So thank you very much.